So let's do a question on distance from pole to focus. And the question says, this is a spherical mirror and this is the principal axis. This is C and the ray of light is coming this way. Okay, it's passing through this. Okay, the given is this is 3 centimeter. This is 3 centimeter and this is center of curvature. Radius of this sphere is 5 centimeter and we have to calculate y. So we have to find y. So the first thing to note here is this is not a paraxial case. The reason being this is 3 centimeter and radius itself is 5 centimeters. So it's considerably bigger than than the paraxial case. So that you have to remember. So now we have to go back and what we have used earlier, we have derived the formula. Let's start from there. So let me reiterate the question again. This is a sphere with radius 5 centimeter. This is 3 centimeter. We have to find y. This is center of curvature. So the first thing here is, first let's connect this with, let's connect this up. Now, if this angle is theta, this is also theta, correct? And this is 5 because this is the radius. Okay. Now, if we draw a perpendicular here, this is 3 centimeter we know. So we know 3, this is 5, right? So if we draw this, we draw this triangle separately, we can say 4, 5 and 3. Okay, so here this will be 4, as you know. By the Pythagoras theorem, because this is 90, this is 5, 3 and this will be 4. So I've written here, okay, we have to find theta. So here we can say cos theta is equal to 4 by 5, or we can say sec theta is equal to 5 by 4. Okay, now we know the formula y is equal to r minus r by 2 sec theta, or y is equal to 5 minus 5 by 2 into 5 by 4, which is value of sec theta. This gives us y is equal to 5 minus 25 by 8, or y is equal to 15 by 8 centimeter. Okay, so that finishes this question. Now couple of sign conventions. So we have to remember focal length of concave mirror is negative always. Okay, and focal length of convex mirror is positive always. First thing. Second thing, For sign convention, for sign convention, for all distances are 1, all distance are measured from pole. 2, the direction of incident ray is taken as positive. So direction of incident ray positive. Okay, and any distance measured along incident ray, direction of incident is positive. So any direction, so any distance along incident ray is positive. Okay, and of course opposite is negative. Okay, now height above, third, height above principal axis. Height above principal axis are positive. Means, if this is, the mirror, and anything above here is positive and this is negative. Okay, and below is negative, right? Now coming on to concave mirror, is focal length of concave mirror is negative. So if we draw, let's say we draw this, let me first draw concave. Now in this case the ray comes like this, and and it goes this way, correct, to focus, correct, and this is P. So basically the incident ray is coming this side and it's going backwards, so it is negative. That is why it is negative. However, if I talk about the convex lens, in the convex lens it goes this way and this way, and focus is somewhere here. So here the focal distance is this way, this way, so it is along incident ray, so it's positive. Okay, so this you need to remember. So now we will talk about the concept of focal plane. Now let's talk about a concave mirror. In the concave mirror, it says that if there are the set of rays of light after reflection. So let's say there are two lines which are, remember in this case, they are not parallel to principal axis. They are actually slightly oblique, but again both of these light rays are parallel to each other. So what will happen is they will hit the mirror here, concave mirror here, and then it will reflect here. Okay, and they will meet at a point. Now what this concept says is that in this case and in the original case, when the rays are parallel to principal axis, then they will meet at focus. Now if I may tilt it more, like if I tilt it further more, let's say if I just make it like this, then in this case also So in any case, the line will meet in a plane which is called a focal plane. So you throw any light, any two rays parallel to each other at any angle, like it may be this, it can be this, it can be this, which is drawn by this light shade, or it might be parallel to principal axis, but each of them will reflect and meet at or in the focal plane. This would be one plane. So this is what it says. If I talk about the convex lens, in the convex lens, again it says the same thing, that if two rays, if you see the rays falling here, then it will meet somewhere, of course, backwards at the back of the mirror, right? But this would be the same plane where, if it would have been parallel to the principal axis, would have met. So this is called focal plane. So if I have to summarize, I can say sets of parallel rays of light after reflection from concave mirror meet at a common point. These points lie in plane called focal plane. If I talk about the convex, again it says the same thing. Sets of parallel rays of light after reflection diverges, means it goes backward. The divergent rays on being produced backwards meet at a common point. These points lie in a plane called focal plane. So let me summarize it to you again. So what is focal plane? Okay, imagine a situation if the rays would have been parallel to principal axis, they would have met at focus, correct? Now in the case which is drawn here by the pen, it is meeting, let's say, at a point O. Let's say this point is O. Okay, now suppose I tilt it more, these two rays are more tilted, right? Then they will meet at some point, let's say here X. So FOX lie in one plane which is called focal plane. Okay, same in the convex mirror. These are the rays which are parallel to each other, falling on the mirror. They are meeting. If they are produced backwards, they meet at this point. If they would have been parallel to principal axis, they would have met at focus. All the points in any scenario for parallel rays hitting this mirror would have met in this plane, which is called focal plane. Okay, so with this I am ending this lecture. We'll continue in the in the next lecture, something more interesting. Thank you.